Hey there folks, this is Mike coming back at you with yet another video on college algebra. In this video we are going to take a look at parallel and perpendicular lines. We're also going to talk about a real-life application of those linear functions and linear equations that we talked about in the previous video. So first of all, just a couple terms that many of you will probably be familiar with. Two lines that are not identical are parallel if they have the same slope. Parallel lines, same slope. So for example, a line that's parallel to the line that has equation y equals minus 3x plus 5, it's going to be any line of the form y equals minus 3x plus b, as long as b is not equal to positive 5. We don't want the lines to be exactly the same, because then they overlap each other perfectly, but we want lines that have the, as we said, the same slope, that are not identical. Just as a very quick sketch as to what parallel lines look like on the coordinate plane. And I stress that this is a very rough sketch. Here's one line, and then here is a line that would be parallel. These are examples of parallel lines. Parallel lines will never intersect each other ever. The other term, perpendicular. Two lines are perpendicular if they form a right angle at the point where they intersect. So perpendicular lines would look something like this. A right angle is formed right here at the point where these two guys intersect. And perpendicular lines have slopes that are opposite sign reciprocals of each other. Another way you can say that is that the product of the slopes of perpendicular lines will be a minus 1. So we're going to use this fact in some of the upcoming problems to see how we find the equation, and then in the process of finding the entire equation, find the slope of a line that's perpendicular to a given line. So first sample problem here, let's find the equation of the line that is parallel to the line with equation 3x minus 2y equals 0, and also passes through the point negative 5, comma 2. Just given this information here, we can figure out the equation for our desired line. So we want a line that's parallel to this thing right here. Well, if I take this and I write it in slope intercept form, y equals mx plus b form, then that gives me y equals 3/2 x. I added 2y to both sides, and then I divided both sides by 2. So this right here, the number in front of my variable x, that's my slope. So I know that I want a line that has slope 3/2. From the previous video, we talked about point slope form. If we know the slope of our line and a point that lies on our line, we can then determine the equation of our line. So combining the slope with our given point, our line has the equation y minus 2 equals 3/2 times the quantity x plus 5 here. And if you wanted to convert that into slope-intercept form, you get 3/2 x plus 19/2. You don't have to change it if you don't want, but that's what it would be for the record. find the equation of the line that is perpendicular to 5x plus 7y is equal to 3 and passes through the point 3, comma 3. All right, so again, we are going to work with this first piece of information that we are given here. Let's take this thing right here and solve it for y. So I have 5x plus 7y equals 3. Well, this implies 7y equals minus 5x plus 3. And then if I divide both sides by 7, y is equal to minus 5/7 x plus 3/7. Okay, so I know the slope of this known line here. It's minus 5/7. I want the slope for the line that's perpendicular to it, though. We said two lines that are perpendicular will have slopes that multiply out to minus 1. So negative 5/7 times the slope that I'm looking for has to equal negative 1. And you can divide both sides by minus 5/7, and that gives you a slope of 7/5, a positive 7/5. So now we know the slope of the line that we are trying to find. It's going to be 7/5. We're given a point as well that lies on this line. So let's take our point and our slope, and let's write our line. Y minus 3 equals 7/5 times the quantity x minus 3. And if you wanted to write that in slope-intercept form, that's 7/5 x minus 6/5. Everything here in the middle is all the work that we have just done. So try this problem on your own. See if you can find the equation of the line that is perpendicular to y equals 8x minus 2 and passes through the point 0, comma, negative 1. Read the question carefully, pick out the key words or phrases that are happening in there. So press pause now. Once you think you have the answer, press play, and we'll see if your answers are correct. All right, so let's see if you came up with the correct answer. The line that we know is nicely in slope-intercept form, so we can easily identify the slope there as 8. So we need the slope that when you multiply it by 8, you get a negative 1. Really easy to find out that the slope we are looking for is a negative 1/8. If we take our slope that we found, negative 1/8, and we take the point 0, comma, negative 1, we substitute it into the point slope form of our desired line. That's this right here, and this is what it would turn out to be if you put it into slope-intercept form. Note that the point you were given is also the y intercept, so you could have just written this guy right here, going to arrive at the same point no matter what. So that is parallel versus perpendicular lines, getting some practice with finding those things. Where can we use these linear equations in the real world? Well, one application is cost, revenue, and profit functions for a company. If you have a company that makes one particular type of product, you can create or work with a linear model to get a sense of what your costs will be, how much money you're going to bring in, and therefore what your profit is. The cost function, capital C of x, is equal to mx plus b, where m is the variable cost, also known as the cost per unit that you make. This is typically the cost of the materials to make each unit, labor perhaps to a certain point, things like that. And then B is the fixed cost. This is the cost of the tools that you need to make the product, cost of the building that you're in. These are the one-time costs, things that you pay for once and then that's it. The revenue function, capital R of X, is P times X, where P is the number of units that you produce and sell. Straightforward. And then the profit function, well, profit is all the revenue minus what costs you had. And whatever you have left over in terms of revenue, hopefully, is your profit. So P of X, capital P of X, is just R of X minus C of X. So we're going to see how we can use these quantities. A company sells tables for $150 each. The company knows that it takes $90 to make each table in materials and labor, and the tools that they needed for the tables, the machinery, overhead, all that stuff, cost them $3,000. Write the cost, revenue, and profit functions. How many tables does the company have to make and sell to break even? So first, let's try to find our cost function. The first couple sentences here, we're going to use that information to figure out our three functions here. But first up is cost. It says here the company knows that it costs $90 to make each table. So that $90, that's our variable cost. That's our cost per unit made. And then the tools, machinery, your fixed costs are $3,000. So this tells us that our cost function is going to be 90x plus 3,000. 90, again, the cost per table made, 3,000, those one-time costs that you paid for, and that was that. We also know that the company sells tables for $150 each. So $150 per table times however many tables we sell is going to be our money coming in, aka our revenue. And once we know the revenue and the cost, we can easily find our profit. It's R of X, there's R, minus C of X. And this turns out to be 60x minus 3,000. So there's the first part of our problem that we had to solve. Now, how many tables does the company have to make and sell to break even? Well, to break even, your revenues and your costs have to equal each other. Or in other words, your profit would be zero. You didn't lose money, but you didn't make money as well. So saying R of X equals C of X implies that 150x has to equal 90x plus 3,000. And now we're just going to solve for x. And we're just solving a basic linear equation like we did earlier on in the course. I'm going to subtract 90x from both sides. That gives me 60x equals 3,000. And divide both sides by 60. That leaves me with x equaling 50. So in order to break even, the company has to make and sell 50 tables. Some follow-up questions here. When does the company make money? When do they lose money? Well, let's answer the first one here. When does this company make money? Obviously, to make money, your revenues have to be greater than your costs. So now we are solving a linear inequality like we saw at the end of chapter 1. I'm setting R of X to be greater than C of X. And we're doing essentially the same work. It's not going to take too long, or hopefully it shouldn't take too long, to do essentially the same calculations and find that the company makes money when X is greater than 50. We're still subtracting 90x from both sides. We're then still dividing both sides by 60. you could have just substituted the greater than sign for the equal sign in our previous problem, and you would arrive at the same point. So when x is greater than 50, the company makes money. Therefore, we know that if the company sells less than 50 tables, then they are going to lose money. Just a quick note here, going back to the previous problem where we figured out where the break even point was. There is a name for the x value that makes revenues and costs equal. We call it the equilibrium point. Just a name that I just want you to, at the very least, have heard. Just know that it's out there. If you see a problem and it's talking about the equilibrium point, we're talking about the x value where revenues and costs are equal. So that concludes our video here on more linear functions and linear equations, parallel lines, perpendicular lines, and where can we use these things in real life. Guys, if you have any questions or comments, please be sure to reach out to me, text me, call me, send me a postcard, send me an email, messages in the clouds, whatever you have to do. Otherwise, until the next video, take it easy.